Hello, everyone. Thank you all for coming to this talk. I'm Nishant Srivastava. I'm an Android engineer working for Soundbrenner in Berlin. Today, I'll be talking about my love-hate relationship with Android Studio. So, in general, like Android Studio is our daily driver. Like as Android engineers, we use Android Studio all the time. And when things break out is when we have to consider other pathways, right? So this is what I would be mostly talking about. Before I start, there's a disclaimer that this talk is not about saying how bad Android Studio is, because it's not bad. It's more about my experience working with Android Studio and like some problems which I found out and possibly other developers also do find out, and then how do they cope with it. So that's what I'm going to be covering here. So let's start with the story first, where it all started. So this was last year, in April 4, 2018. I joined a new company, and I inherited an Android project, which was pretty big. It was a typical Android project where you had multiple use set up, you had native code using NDK, and then there was common dependencies, like you would use Retrofit, Dagger, RX support libraries. And my system was a MacBook Air, early 2014, Core i5, 4 GB RAM, and 128 gigs of SSD. In fact, it was the same laptop that I'm using right now. So what happened was that I tried to build the project for the first time, and something happened. My build times were around 37 minutes. So this is like, I just downloaded the project, and I started working with it the first time. So the initial guess is that maybe Gradle was not able to cache anything, Android Studio was not able to download dependencies. So it would be fine if I run it the second time, because everything would have been cached. So I tried doing it for more number of times. Like I did it for second, third, fourth, fifth. Nothing happened. It was still around 36 minutes of time of build time. So as always, what people do is they try to figure out what's the easiest way to fix this. And the first thing that I tried doing was try to make some Gradle config fixes, which is pretty common. And I will be talking about those in the later slides. My build time was brought down to 28 minutes, which is pretty nice because I was able to shave around like 9 minutes, but still not acceptable because you cannot use it in the practical scenarios. Like imagine you being at work and spending 28 minutes to build this one project every single time you want to test one line of code change. So I had exhausted all the possibilities. I tried working with other possibilities that I could make changes in Android Studio. I could tweak some stuff in the code, but nothing worked out. So I had no choice, but I thought that I'm just going to ditch Android Studio. So I switched over to something like a VS Code and using terminal for my builds. And this is like me tweeting about it, that this is it, that it's not working forever. And I'm just going to switch over to terminal to start building my project, to assemble the APK, and also installing it on an Android device. So the results for this was, surprisingly, the build times were down to 3 minutes. I had like 89% of reduction. And I'm not making this up. Like I have a screenshot of here, like how it looked like. So Android Studio build times were around 28 minutes, 7 seconds, and 96 milliseconds. With the terminal build, I was able to bring it down to 2 minutes and 52 seconds. And this is like a consistent one. If you try to run it multiple times, you could get it around like 2 minutes and 15 seconds, 15 milliseconds also. And there's a link for my blog post, which I wrote at that time, like how I did that. And when this happened, I came to understand that there's a certain issue that we are having here. It's not the code that we are writing, it's mostly the tools that we are using are causing these slow up. So I had a bad experience. In general, I tried to look up how other people are also experiencing this bad experience. So I came up with like different sections of what's the state of Android Studio right now. And again, this is my personal experience as well as some other developers. It has nothing to do with Android Studio being typically like this. So let's talk about the state of speed. Android Studio in general was very slow for me. And turns out it is slow for a lot of other people. So here's a tweet from one of the GDs himself. And he's basically saying that I spend most of my life waiting for Android Studio to update indices. And then I do waiting for a Gradle build. So what indices here is that Android Studio needs to build a map of your code base every time a code changes so that it can provide you code intentions and like more suggestions on the fly. So it can check your code. So to do that, it has to index your code. And that's why it keeps on updating indices. If you make more changes, it will go and update it index again. So it's a forever loop. the state of reliability for Android Studio. So in general, Android Studio works for everyone, but sometimes it doesn't. And when it doesn't, you don't know why it's not working, because everything else was functional in the morning, and by the afternoon, it just breaks. So for me, in this case, my project was functional in the morning. During afternoon, when I came back from lunch, I just compiled my code, and this is what I was able to see, a whole list of red lines on the side, basically showing there's a lot of errors on the code. People come up with solutions that if this kind of a thing is happening, then just go ahead and delete idea/libraries folder, which is a configuration file for IntelliJ specific idea ID itself. So they say that, but again, this is it's not reliable enough. You don't know what else to delete. You're not sure if you can just go ahead and delete this, and it's going to break up everything else for you in the project. So it is quite finicky, and no one has the right answer to it. One day this works, the other day it might not. And then the state of choice selection for Android Studio is changing a lot. It's becoming more forced. You are now forced to do a lot of things that you wouldn't have to do it. So this guy here, he's another GDE himself, and he's mentioning that when he uses Intellij Idea, on which Android Studio is based off, he can work with Android Gradle plugin 3.2, 3.3, 3.4 beta, and 3.5 alpha without any issues. But if he tries to do that same with 3.3 stable, he gets the option of saying that this version of Android Studio cannot open this project because it's not supported, and it's being forced onto him that this dependency is required. Again, that's something that is how software should work. The dependency should be specified. But since Android Studio is built on top of Intellij Idea, then Intellij Idea should also not work. So the choice of selection is being forced upon to the developers, in my view here. And then the state of the new tools. So what's happening is that as Android Studio is getting developed, every few versions, like 3.3, 3.4, 3.5 beta, and then Canary versions, all of these, Android Studio team is adding new profilers and new tools to the system. And these systems are limited to Android Studio. Again, you cannot run these specific profilers, the ones that you're seeing right now, the energy profiler, the memory profiler. The views that you're seeing right now, they run only inside Android Studio. There's no plugin that you can plug into another IDE, like an Intellij Idea itself. It doesn't work, and there's no command line tool to even trigger it if you wanted to trigger it somewhere else. Then there's constraint layout editor that is built specifically for Android Studio again, and you cannot deploy it again. Now, why am I bringing this new tool section? Because in the past, there has been other tools that have existed outside Android Studio, and they've functioned pretty nicely. There was systrace, there was hprof, there was a lot of like these profilers that existed, but they are not. There was a hierarchy viewer that you could go and use it even without Android Studio, but they don't exist anymore, or people don't use it. They haven't been updated for a long time. So that's what the state is right now. And then the state of memory consumption. So what's happening right now, if you look at the screenshot, is basically pointing out that Android Studio is taking in 1 gigs of RAM. Now, my system right now, the one that I'm using right now, has 4 gigs of RAM, which is pretty OK, and it's fine. But as a system for which where we only write code and deploy code, I don't think so we need a system that needs to have more than 2 gigs of RAM. There are people, those who are making jokes about it, that what on earth requires 1.5 terabytes of RAM to run, and someone responds back, Android Studio. People are not making this up. It's because they are making jokes because that's how the situation is. If you have 16 gigs of RAM, then also Android Studio fires up your fans, and it is running super fast, consuming a lot of your memory. I have a 32 gigs of RAM Linux system. If I start Android Studio, my system goes into hyperdrive, and basically it consumes a lot of memory. I'm possibly running like 8 gigs of RAM with only Android Studio running. And that possibly also includes running an emulator alongside. But yeah, it is consuming a lot of memory. And the same goes for the CPU too, because in this same scenario, you can see it's gone up to like 250.6% of the CPU cycles are being used. And I'm not even running a bigger project. I'm just opened up a new Hello World program, and that's what it is. As soon as it starts up, it just goes up. Even better, this is one person who posted this on Twitter, where they said that they tried to install Android Studio. It went into overdrive, consumed like 1,000% almost of the whole CPU cycle, and at the same time, it sort of deleted their text editor VS Code and terminal shell script config. So it's like sort of Android Studio fighting back that, no, I'm not going to let other editors exist in the system. So these kind of situations are also happening, although this is a very not common thing to happen, but it is happening. in the wild. And then obviously the state of the updates and the versions that you're getting. You have the alpha, you have the beta, you have the canary version, and also the stable one. And people are not 100% sure which version to use anymore. If you are on the stable, you know how buggy it is. So you switch over to beta, and you expect it to be stable. But beta is also not as stable. So you switch over to canary, which is completely broken. So that's how things don't work out, right? So the state of the versions and updates is also not going super nice. So to summarize everything, Android Studio in general is super slow, it's finicky, it forces defaults and deviates from its base. New tools are being limiting here, and it uses a lot of memory and CPU, and has versioning problems. So comes back to this basic problem which actually made me look into all this, and that is Android Studio is slow. So we're going to jump through this and try to understand why it is slow, and then what is the solution for it, and then eventually come to a point where I will explain how my workflow now turns out to be. So the problem here is that Android Studio in general is slow because it has to have certain Gradle configurations. By default, what it comes with, that doesn't work out of the box. And then you have every few times when you're changing something, the indexing is happening. You have a lot of default plugins in place, which is also not required. And then you have to have this code inside, the inspection, the intentions that you need to have. And these basically cause a lot of problems. So let's start with trying to fix the Gradle configuration problem. We're going to be configuring Gradle for the speed here. The first recommendation is to use the latest Android Gradle version. And the graph that you see right now is basically showing the incremental compilation of 1,000 modules in a Java project, where it shows over the versioning of Gradle as released, how the time of build has gone down. So as soon as you can, you should update your Gradle version. Here's a caveat. The latest Android versions, the latest Android studios are the only ones that support the latest Gradle version. And that's a problem, because now that means that you have to be on the Canary version of Android Studio. Otherwise, you cannot. They force you not to update your Gradle wrappers. So if, say, for example, you are there, apart from that, there are other options that you can also enable, and this is very common to Gradle. It has been around with other versions, and that is that you could enable build cache, which is basically saying that you can reuse the output that the last invocation of Gradle introduced. So if you started a Gradle build, it cached a lot of things in the build. It's going to reuse the same thing if that part of the code has not changed. So you can just go ahead and set up a flag that says android.enable build cache, set it to true. The another option is to have a dedicated process running in the background, which will make sure that the performance of Gradle does not degrade. It's always available, and it can keep on processing. So that one is called a Gradle daemon that you can enable too with a flag. All of this goes into the gradle.properties file. You can set it up in your local system itself, or you can put it in your project also. This one is something that maps up to a lot of people, but we are restricted by the amount of memory we have. So for now, what it's saying is that we can give JVM, the Java Virtual Machine, more memory. But if you do not have enough RAM, then you cannot. Like for instance, in this case, I'm giving JVM 2 gigs of RAM, right? But if my system supports 2 gigs of RAM, I cannot do that. So it's a bit of limiting, but the more memory you give, the more processing the JVM can work through. And then obviously, if you start doing tasks in parallel, you're obviously going to see an increase in speed, because a lot of things are getting generated and being built upon at the same time. So setting that flag also can give you some speed boost. The next problem that we were talking about is that reducing the indexing. Now, if you make a file change, which is pretty common, you will always do that. That particular change will trigger an indexing state, which is what I'm showing in the screenshot at the bottom. It will trigger an indexing state. But how can you avoid that? Well, there are some instances that you can do that, and that is when you're using annotation processor. An annotation processor is basically going to generate code for you based on the annotations that you have put in your code. So if you do that, new code is generated, new indexing will get triggered. So if you avoid using annotation processor, you get rid of that kind of indexing. If you use implementation versus API, this is a new way of how dependencies are referenced in Gradle since version 4.0. And this basically means that how many modules would get triggered into a build system when the build is triggered based on how they are referenced. So say, for example, there are like 5 dependencies in a row, one after the other. They will all get triggered if you're using API. But if one of the other is just using implementation, they will not all get triggered. So only one of them would get triggered, which is nice because you don't want to run the build for other modules. And then, obviously, this is a very common thing to see. People don't notice this. In your build flags, what you do is that sometimes you would want to add in your version name the commit ID, just so that you can reference it easily, right? But every time you do that, the build is running when it goes through the commit ID and it appends it to your version name. That's a change that goes into the manifest. So again, the indexing would go through. The building will go through, and the indexing would go through. So you will be losing time, right? That's why build process are so long. And then this is very important because I was going through this problem, I had switched over to terminal builds myself. I was also trying to find out why the problem existed. I had a lot of talks with the engineers from Gradle and from people, those who are working with the Android Studio code base, and no one could point it out. And that's because no one knew what the problem was until I figured out that there's a lot of plugins that are being used in the Android Studio by default, which we don't use. And the reason that triggered me is because of this particular thread in Reddit. And this is from Jake Wharton himself. He's basically saying that if you have the plugins enabled, your Android Studio is anyways going to be very sluggish. It's going to go very slow. So what I did was I basically disabled all my plugins, apart from the ones that I need, like I need the Android one, I need Kotlin, and the very basic ones. And I could bring my build down from 37 minutes to 6 minutes. It's the same machine. I'm just trying out different possibilities of how it would work through. So what this meant is that, OK, now I could use Android Studio, I could use Intellij Idea, any of these, and I could just disable the plugins to get it working in a somewhat usable build time. So that is like one problem that you can solve by disabling plugins. But then there's this code inside that also you have to use. You have to get code suggestion, you have to get code intentions, and all these different options. But if, say, for example, you want to still save some time, you're already in a crunch situation, your system is not responding, or like you just want to have more juice from your Android Studio, what you should do is that you should disable all the intentions. You could ideally go into the preferences and disable all the inspections, but I don't suggest that because you will have to go and then enable them again whenever you want to use it. So what I suggest is to use something called a power save mode that's already in Android Studio. And what it does, it disables the code insights and any background tasks that are running. So it's just helpful to just enable and disable it. Very quick and easy. So this brings me to the original solution that I came up with, and that was the terminal to the rescue. Because I'm be talking about how Android Studio is sort of broken for me, I had to find a solution to work with the terminal. And in that scenario, I had no other IDE to help me around. There was only Visual Studio Code, which I could write code in, and then I could use the terminal. So how did I actually start using it? So the first thing that I want to understand is that when I'm starting to switch over to something that's terminal-based, there are a couple of things that Android Studio does for me, and how would I map it back to the terminal? So the first thing that comes to mind is to try out something that will enable me to talk to the Android devices or to the virtual devices. That's when Android Debug Bridge comes in place. This, I guess most people know about it. It's a command line tool. It's shipped with the Android SDK, and it's also like allows to interact only with the debuggable Android devices. That means that you have to go into your developer setting and enable the debuggable flag. And you can basically just use as ADB and then the params password. So what you can do with it, let's see that. Well, you can try installing an app, which is ADB install in the part to the APK. You can try to uninstall an app. You can say ADB uninstall and the package name. You can copy a file from system to the Android device. Again, there's a certain whole command that you will give. ADB push part to file, part to directory on device. And then to pull the file from the device back into the your system, you will do Android pull. So this is pretty common. You should be able to work with it. So that just allows me to build up APK and install it on the device. Good, I can do that. Now, other tools that also ADB provides is that it can also help me work with the activities, as in I can trigger an activity to open. For that, I have to log into ADB shell, and then I have access to Activity Manager, emulators, Package Manager, Device Policy Manager, Logcat for logging things out, dump sys, and many more. So ADB in general is my Swiss Army knife to do anything that I want when I'm talking to the Android device. The next thing that I needed was that, OK, I have ADB, but I still need to build my project. And in general, Android Studio in the behind the scene uses Gradle as its build system. So I should be able to use Gradle directly. And that's what I'm doing. If I wanted to trigger a build process right now to make project, the equivalent would be to call the Gradle wrapper, Gradle live, assemble debug. And when I do that, I will be building my project. So that's how I think most people would do it, and that solves ticks off me able to build my project. So I'm pretty happy with this. Now, the next thing that I would probably want to do is that I could do in Android Studio was be able to check the structural correctness of my code, which Android Studio has lint for. You have something called analyze inspect code, which will analyze your code and run the lint for you. But lint in general is basically a set of tasks that you can run. So you go through Gradle live and you trigger the lint. And it will, again, give you a bunch of issues, problems that you can fix. What's nice is that it will give you a web page, which is very nice and pretty. They have styled it up, and they will set it up to show you what all issues you have, and then you can go and fix it. It even has other possibilities of how you want to fix it, right? So it will suggest you those things, which Lint already does in the Android Studio. So at this point, I'm able to check my correctness, I'm able to build my project, and I'm also able to talk to my device. So these 3 points are all ticked up. And then the next one comes in. This is actually not related to Android Studio, but is something that I would anyways use it, and it's part of my working terminal workflow. And this is called screen copy. They type it SCRCPY for some reason, but it basically helps to mirror your device. So you don't need an emulator. You can directly use your system or your another device, dev device, to mirror it and then work with it. So that's what I use it. You can even show touches, switch off the screen, record while mirroring. All this stuff is definitely possible. So now I can even talk to a physical device and mirror a screen, which is great. The next thing that I wanted to do, which Android Studio can do, is be able to decompile my classes. You can look at all these classes in your Android Studio by clicking through command click, and you can jump into the whole class files, because Android Studio comes with a decompiler, Java decompiler. But that's not available on a VS Code or a terminal. So I searched for this. It's a Google project, by the way, but it is not supported by Google for some reason. It comes under the github.com/google/repository. But Classy Shark, in general, is a tool for decompiling and analyzing your SO files. SO is your native code, your APK files, your DEX file, your class files, jar files, AR file, all the different versions that you can think of. You can load it up into Classy Shark. It's a standalone tool. You can trigger it by saying java-jar and the jar file itself. And then you get to work with it. You get to see all the classes, all the methods that are being used here. So this is how it looks like when you load it up. I'm loading up one of my applications, and it just decompiles all the classes and shows me a list of all the libraries it's using. So it's very easy for me to go through it. And then it also has this super nice thing that's called the method count, which you can also probably have got in an Android Studio, something called method count plugin, which is not there anymore. They just deprecated it. But this thing still works, and you can use this to show all the dependencies that you have with the DEX count and method counts that are being used in a nice graph. So it's very easy to use. I like it. I still use it. Even though I'm using Android Studio now, I still use it to check my graph for a bigger project, because it's easier to analyze and know where the method count is going in. So now I am also able to decompile my code, but what about language consistency? Again, Android Studio and Detekt in general is a tool that will help you analyze. It's like a static code analyzer for Kotlin, but you can also put it inside Android Studio. It's not limited to a command line state, but yeah, I use it on the command line because it's easier to maintain. The sole solution being here is that I can pipe this output from this command line into another command too, which you cannot do inside Android Studio. You get a plugin, and it just generates an output for you. So that's why I prefer using Detekt on the command line. So it's highly configurable. It will allow you to do a lot of things. You can always do that. When you run it, actually, it looks like this. And it's run the usual way. You run it java-jar and the jar file itself with a --debug just to show a lot of more information. It will generate a complexity output. It will generate a project statistics and a lot of warnings, which you can go and cross-check to fix it. So Detekt is one of the nice tools to also have in your arsenal when you're trying to work only on the terminal side. So everything set up, build, talking to Android devices, and also being able to lint my code. I still need to run it on a virtual device, on an emulator. So I don't know how many people know about this, but this has been around forever. Android's SDK comes with the AVD Manager as a command line tool. So you're used to clicking that icon on the toolbar and to trigger up a window that says, OK, create a new Android virtual device. But you can also do that with the AVD Manager. This is in the Android SDK tools bin folder. And what you do is that you basically just call the tool. You say AVD Manager, list me all the Android virtual devices you have. You can create a new virtual device. The syntax is pretty clear. It says AVD Manager create an EVD with a name my AVD and the kind being a system image, Android 29 APIs, Google APIs, and is an Intel x86 image. So you just run this command, and then you have a new virtual image with the name of my AVD. If you want to remove one, you will say AVD Manager delete AVD -n or -n, and then the name of the AVD. Why would you want to remember these commands, though, right? So we'll be talking about how we can automate it towards the end. But this is important to know that this is a possibility that you can work with. So with, say, whatever we were able to do in the AVD Manager, I had to build an AVD itself, which had platform 29, but I don't have that. Now, the usual way of doing this is that you will go into Android Studio, click on an SDK Manager, tick on a few options, and download the platform 29. But I don't have an Android Studio at this point. So what I'm going to do is I'm going to trigger another tool that is also shipped with Android SDK. This one is under Android SDK tools bin folder, and it's called SDK Manager. It's been there forever. People just don't use it because you have a GUI version for it. So again, with the SDK Manager, the same way you will go in, you will say, you can list all the repositories and the packages. You can take SDK Manager, provided a package. In our case, it would be platform tools and platform 29, because I'm looking for a platform tool that is running API 29. So I can just go ahead and download that. You can install it. You can update all your dependencies, which is super easy. You just trigger these commands. By the way, all these commands that I'm talking about, they run on the terminal, and they are very useful if you're also trying to do this on a CI/CD system. You don't have Android Studio there either. So if you want to trigger something in the CI/CD system, you just call SDK Manager to list packages, maybe grep for a particular package name, and upgrade it to. So you can all do that with this. So that said, this brings me to one other specific tool that people don't talk about, and this is called Battery Historian. You remember I said Android Studio has these very specific profilers, the energy profiler in general, let's take that, and you cannot use it outside Android Studio. So that's the reason I couldn't actually work with an energy profiler anymore, so I had to find something else. And turns out Google has had this battery historian for a long time. It's not even since, I think it's 2014 or something. It's been around. It's a Python-based tool. It is used to inspect battery-related information when your device is not connected. So you start a battery stat information, generates a file on your device. You pull that file into your system, and then upload it to the battery historian. As you do that, what it will give you is it will give you a whole list of options in a graph. And it will also specify exactly where these things are using the battery. So you can see the black line at the top is going down. That's how your CPU is running. At the same time, on the side, you can see the battery is depleting. So that's what it's showing. And then how many times the app process waked up, the kernel only uptime, and all these different informations. You get even in-depth information like this, where you can drill into more information to find, like, okay, I'm going to be looking at one specific kind of action that happened on my device, and what was the state of my operating system at that point. So that's where Battery Historian comes in. And it's very useful. Even if you, say, forget Android Studio one time, you can still use this. And it just works out of the box. And last but not the least, this is about the Intellij Idea as a tool that I've been talking about, that there was a certain time when, okay, I couldn't use Android Studio, so I had to switch over Visual Code and also to terminal-based all the building of my app. But then I also tried Intellij Idea, and for some reason, it just performs so much better. There is no problems. My assumption is that I later learned that maybe it's the plugins, because that's where the difference comes in. Intellij Idea can be used for Android development. I mostly use Intellij Idea now. I don't use Android Studio. I do use still terminal builds at the same time, but for writing my code, I use as an editor, I would say, Intellij Idea. The community edition is free. This is what Android Studio is based on. It is way much faster to develop on this. It's just way more stable. It gets way much faster updates. Every quarter there will be an update. And also it has the full plugin support. Everything that you can put inside an Android Studio can also go inside an Intellij Idea if it's a plugin. If it's like an energy profiler, I don't think so that could go in because it's not a plugin. It's not isolated from Android Studio. So that's where the con comes in, actually. You don't have energy profilers. You don't have the constraint layout editor. You also don't have the quite recent new project structure dialog box where you could go in and download dependencies. That's not available inside Intellij Idea. So all these tools together, they just form my whole arsenal of tools to do Android development. And I don't have to actually run them through or learn all these commands, because what I do is I go through the automation process of this. So I'm going to walk you through one of the examples here, how the automation is going to work. So imagine me right now. I'm going to be creating an alias. An alias is a named version of a full set of commands on a terminal that you can put inside your bash rc or zshrc file. It's a configuration file for your terminal, where if you put it in, these commands are available on the next start of the terminal. So what I do is I create an alias. For example, right now I'm going to be creating push release to device. And what it does is it uses adb command to push a file called apk release-.apk to the folder on my device called sdcard/downloads. Okay, so at this point, I'm in my project. I go in and I just run push release to device. So a generated APK file would directly get pushed into the device. It's not getting installed, it's getting pushed. So it is in the device right now, but it's not installed. So I'm going to take this further. Now I'm going to go and install this APK. So what you see right now is a very complex command. You don't have to worry about the command, but the point is that now I can play with all these commands. And there's a section of each of these commands that is piping into the next version of the command. So what you see right now is an ADB devices, which is going to get me a list of devices. I'm going to see a name of the device, and then I'm going to see a serial number of the device. The next it says is take the last value, and from there, start cutting the value that I want after the name section. That is the serial number. Once I have the serial number, I use X arguments to pass it into adb-x, and there I'm passing x install -r $1. So adb-s x install -r is another parameter-based installation process that's saying go ahead and install the APK. The $1 replaces with the last argument. So I had the serial number. I could just go ahead and replace that. So that's what it does. I don't need to remember this all the time. I created this one time, and now I just go ahead and I say APK install. And it will take my APK, or even doesn't need to understand which device is connected. It will take that from the Android devices command. So it is taking my APK, is basically pushing it to the device and installing it without asking me any questions. I can take it a bit more further, because now I'm talking about APK installations. Think about, I also need to build it, because that's what Android Studio does, right? Like when you hit build, then it goes and builds it and generates an APK and installs it on your device. It also does one more thing, but we'll come to that one part. So at this point, what it does is it will say Gradle Gradle wrapper, assemble debug, build the whole APK, and then go and install it. And then I'm saying APK install space the APK name. That's it. I don't need to remember the whole program. That's how I automate everything up. So that done. There's one more thing that I said Android Studio does. When you hit the play button, what Android Studio would do is that it will also launch the activity as soon as the app is installed. Now, for some reason, there is no command for that. I mean, no Gradle command for it. There's no command for building and install or something like what already exists. ADB also doesn't provide you that option. But what ADB does provide you is something called a monkey tool, which basically what it does is that if you trigger a monkey tool, it will throw random user interactions on your device that's connected. It could be an emulator, it could be your standard device. So when I was doing this, I obviously wanted to simulate the same functionality as Android Studio would do it, right? So I wanted to do that same thing. What I did was, I'm going to break down this whole big command that you see. It says adb shell monkey -p. Up till now, what it's saying is trigger a monkey command by passing it -p is the package name. And then after that, there's a small tick, and I go on to write a whole bunch of command. till the end where it says 1. It's on the third line. It says 1. So what it's saying is, monkey tool, for this package, send one click command. That's it. Okay? So the code in between those ticks is basically saying, it's taking AAPT tool, that's again part of Android SDK that you can always find, and it's trying to get the package name from it, from the APK. So I'm not providing the package name by typing it out. I'm giving it an APK. The command AAPT uses that to extract the package name, puts it in place for ADB shell monkey -p, and then the package name, and then sends one specific command to trigger that activity. And that's what it does. As soon as I hit enter for launch debug APK, providing it the APK obviously at the same time, then it will take that APK, go in, install it, and then trigger that up. And to summarize this whole thing that I just did, I built one last command, which I just combined with all my terminal commands. And this one says build, install, launch, debug APK. Now, it has a build and install APK, the command that we had in the last slide, which will build the project, install the APK, and the last one would basically go and click on it. So that's like just one way of demonstrating how you can use terminal to do exactly what Android Studio is doing. Obviously, it makes no sense for people to do this when you already have a functional Android Studio. But it did make sense for me when I was using this back in India, and I had no other means to get a better laptop. Nowadays, what we have is that we have 16 gigs of RAM, Mac Pros. Even nowadays, you have 32 gigs of RAM, and there's no issue. You have SSDs, and everything is functional. But for people, those who actually don't have those, this thing actually works. And as I already demonstrated, like from 37 minutes to going to 3 minutes, my whole tool chain was functional, and I had no issues. I probably kept on using this for like five months, and then eventually started bringing Intellij into picture and using less of how I'm doing all this. But all these terminal commands in general help me to set up my CI/CD system too, because sometimes I want to test it, and I would take screenshots also. So apart from those, there are other, obviously, like, as I said, I will take screenshots. There are other commands that you can also execute. Again, ADB provides you all these options. There's a screen cap command, which will allow you to take the screenshot of the project as it is running, as the app is launched. There's a remove app. You can go and uninstall an app directly by just providing a particular value for it. And then you can clear the data. Again, this is also provided as sort of a plugin. It's called ADB Idea, I think, which helps you do all this stuff from the GUI. But they all, behind the scenes, actually do the terminal thing that I'm doing right now. So all of this is nice and good. You can do it on the terminal. But obviously, some of them don't make sense to do it so comprehensively, right? You just want it for your one project. And that's where like people came in and they started building an Android Gradle plugin for it. The company called Novoda built a Gradle Android command plugin, which abstracts all of this and provides you Gradle task for it. So now what you will do is, instead of building these commands yourself, you will set up this particular Gradle plugin, and then you will just say Gradle Liu install device debug, and that will install the app. And you can even say Gradle Liu run debug, and that's going to install, and it will launch it, the app on your device. So there are obviously other options that I was made aware in the future, but when I started doing it, they were not present for me. So you can obviously go ahead and also contribute to this plugin so that it makes life easier for other people. But yeah, this is also existing for people, those who want to do automation for their projects. So I talked about all the bad experience I had, and then what's the solution for this. There's also a section where I love how Android Studio is progressing. And that's the love experience that I show it here. And that's mostly about how they have been working only towards making Android Studio better. So there was a time when Android Studio was jumping from version to version and adding multiple features. But then Project Marble came in. That has been released, I think, last year, where they started saying that we are going to be focusing only on the performance of the Android Studio. So no more new features. It's only about performance. It's only about making the UI and UX as smooth as possible, and also stability and reliability of Android Studio. So they have a lot of these blog posts that are already in place. I'm not going to be talking about it, but what I will make you aware is that there are some improvements that they've already done. That's for the layout editor. It's super smooth. It's becoming more performant. There are more UI, UX-based changes, which they heard from other developers, and they made those fixes. The instant run, which everyone despises, is gone. they heard us, and they now replaced it with something called apply changes, which is a completely different way of doing it. And that's just progressing in the right direction, right? And then also there's been a lot of updates to the emulator. The performance of emulator is super nice. You have snapshots now, as in when you start your emulator, instead of taking a lot of time to boot up, it's going to start up instantly because it's saved its states already. That's what a snapshot is. And then obviously there's a lot of fixes that keeps on going for the lint, and a lot of tool chain that they have. Even with the profilers that are coming in, they're all being updated. And then there's one other specific tool that I wanted to talk about, and this is really out of the way that they did it, but there's something called APK Analyzer. You might be familiar with what you're seeing on the screen. This is called the APK Analyzer. This is the GUI version for it. But turns out the APK Analyzer also exists as a command line tool, which is really weird because they have been building constraint layout, editor, and profilers and everything, and they don't have command line tools. But for some reason, APK Analyzer has that, and that's what I really like about it, because now I'm not tied to Android Studio to do this. So one of the examples that I'm sharing here is that how you can actually get the file size of your APK. You just use APK Analyzer. -h is a param that you pass to make it human readable. APK is saying it's going to analyze the APK. And then what kind of a thing in the APK is going to be a file size, and then you pass the APK to it. And the output for that is in the command. It says 1.7 MBs. It goes beyond that. You can do other kind of things. You can say, I want the summary of my package, like what's the package name, what's the device name, what's the device number. So you get all that information. That's also in the comment section. And then even better, you got the download size if you were to use APK Analyzer. So you see this in the GUI. It would say, this is your final size of your APK, but the reduced download version would be this. This is what you get from. You pass it as the parameter download dash size, and it gives you the download size is going to be 1.4 MB instead of 1.7 MB. So the compression ratio is taken care of. There's a lot of more information on this, and I couldn't obviously cover all of it, so I put the link in here. You should definitely go and check it out. All the command line tools that I talked about, they all have their documentations. Definitely give it a try. There's one more thing that maybe I can mention. It's not in the slide, but that's more about ADB doing some very magical things that maybe you might have never heard about. And I was quite recently doing this, and that ADB in general talks to the device, right? And it sends commands to it. But there are other ways for you to actually simulate touch gestures on the device once you run ADB command for it, right? So there's a specific command that you will run, and you can simulate those gestures. If you were to automate this, you could run it for a different variety of tests also. So if, say, for example, you don't have the whole setup for setting a testing tool chain, you could just simulate your touches. The manual touches that you're doing, you just run it once, and then you run your script with ADB repeating the same touch events. You already automated your manual test into an automated test. That's like a layman's version of doing things, but obviously there are better tools to do it. And that's it. That's a bit of a link and references that you will have, which you can always go back and check. There's a lot of documentation for it. And if you have any questions, you can ask me. No questions? If any problems that you guys have probably with the Android Studio running it, or even like with the current version of how Android Studio is functional, I can even talk about that. I've done quite some time with that. Okay, I guess no questions. So thank you.